So I would start out by subtracting 33 from each side. So we'd have x squared minus 8x minus 33 is equal to 0. And that might already be done for you in the problem. But once it's in standard form, then identify a, b, and c. So in this equation, what is the a value? A is 1, b is, and c. Okay? And then we just substitute these into our quadratic formula, which again is up here. So it's x equals, and this is just showing you're solving this equation for x. So if your variable was something different, if it was y squared minus 8y minus 33, we'd have y equals here. So that's just what you're solving for. So x equals the opposite of b, so that would be positive 8 in this case, plus or minus the square root of b squared, so negative 8 squared, minus 4 times a is 1 times c is negative 33, all divided by 2 times a, which again is 1. So all divided by 2 times 1. And make sure you have the entire quantity on top divided by 2a. What I see students do is they only divide the square root by 2a, and they're missing that initial opposite of b part of it. So you have to simplify the top before you can divide by the 2a. And that's just the setup. Now, from here, you just evaluate what part of this expression should be evaluated first.
The square root.
The square root, yes. So when you think of order of operations and grouping symbols is typically where you start. The square root is a grouping symbol. What is inside of the square root needs to be simplified first. And whether you do that in separate steps or all in one step, that's up to you. You just have to be careful with order of operations and what calculator you're using as well. So I'll explain what I mean by that. So I'm still going to have the 8 plus or minus the square root of. Now, a couple of reminders with using a calculator. I'm just going to grab a different one where you can see the screen a little bit easier. If you are actually typing in negative 8 squared, because sometimes if there's a different number here like negative 24 squared, you might not know that off the top of your head. But if you're actually typing this in your calculator, remember to type the negative 8 in parentheses before you square it, because it should be positive 64. So that's where one simple mistake occurs is students will say this is negative and then it throws off what's in their square root. So that's 64. And then now on the calculator I have, if you have a scientific calculator like this, I can just type in what's remaining here as one line and it'll calculate. Like from here I could just type in minus 4 times 1 times negative 33, and it's going to show me that everything inside of the square root simplifies to 196. Some of you have a calculator where every time you type in an operation, it's automatically calculating the whole time. And if you have that calculator, you probably know what I'm talking about. So in that case, you would need to figure out, you'd have to follow order of operations. You'd have to actually figure out the negative 8 squared, that's 64. And then you'd have to figure out this product, the 4 times 1 times negative 33, which would be negative 132. And then you'd have to type in 64 minus negative 132 to get the 196. So just make sure you're following order operations, you're using whatever calculator it is that you have, you're using it correctly. Because I know different calculators, they'll work differently with how you have to type things in. And then if you're not getting the right values, make sure you let me know so I can help you with your calculator. And then this is all divided by, and I can multiply the 2 times 1 right away as well. So it's all divided by 2. And then what would you have to do next to simplify? The square root. So is 196 a perfect square? Can you take the square root? If you some yeses, what is the square root? 14. So 8 plus or minus 14, all divided by 2. Now, what would you do if it wasn't a perfect square? Like, I'll pick a smaller number, not in the hundreds here, but what instead of having a perfect square here, what if you had the square root of 8 into what? 4 and 2. So if I want you to still leave your answers in exact form, like I talked about yesterday with completing the square. So if you get a number that is not a perfect square, I don't want you to type it in your calculator and give me the decimal. I want you to simplify the square root by finding the perfect square that goes into it. In this case, it actually was a perfect square. I'm just saying for future examples, if that comes up, simplify the square root. Don't give decimals as your answers. And then from here, 8 plus or minus 14 all divided by 2. Because I no longer have a square root, I can actually find what two values x is equal to. So this really means one of my values is going to be x equals 8 plus 14 all divided by 2. The other value of x is 8 minus 14 all divided by 2. And careful, too, with how you type this in your calculator. Again, I'm trying to point out common mistakes I see. If you just type this in, if I just type in 8 plus 14 divided by 2, okay, without parentheses, I'm just typing it in and I hit enter, it tells me it's 15. That is wrong. Because when you actually evaluate this, you have to do 8 plus 14 first, which is 22, divided by 2 is 11. So careful how you type this in, because I see, in this case, I would see answers of 15 often, because students are just typing it in. When you type it in like this, your calculator is dividing 14 by 2 and then adding 8. It's following the order of operations, so just be careful. If you want to type it in as one line, you'd have to put 8 plus 14 in parentheses and then divide it by 2 to get the right answer. So we have 11, or 8 minus 14 is negative 6, and then divided by 2 is negative 3. So positive 11 or negative 3 would be the two values of x. Questions on example 1? Okay, so there are 3 more examples just using quadratic formula. The reason I included 4 examples is all of the solutions work out a little differently. So what I'd like you to do is you're going to be working through these 3 examples, and I'm going to be stopping you at points to check in with everybody in terms of simplifying. But I want you to work on example 2. I'll be walking around. I'll double check we all have it. When you're done with example 2, you don't have to wait for me. Work through example 3, work through example 4. And then we'll kind of come together to discuss them before we move on to the last piece. So today is just kind of, the next 3 examples are practice for you with quadratic formula, and like I said, the solutions all work out a little bit differently.
Yeah, I was like, why did you eat chicken? I did. Yeah, she went on the I don't know, when I got there, she told us her major, so I guess she's just a little bit. I hope she calls you, and I'll really be so ready for like, what's time is that?
All right, I think everybody has number 2, so just double check. It should be positive 17. And then 3, it seemed like most of you already had an answer. I just want to double check that we all have had a chance to answer number 3. I am going to talk about how to simplify it further than maybe some of you have. Same with number 4. So just make sure 3 and 4 also do. I just want to make sure everybody has had a chance to work on them. I know some of you are ahead. But I want everybody to get a chance to look at it. There's a way to simplify it, and I'm going to talk about that, but for the most part, yeah, that's basically yeah. All right. We are going to go through these. I know some of you might still be finishing up the last one. Here's example 3. It is not completely simplified, but I think this is where, and some of you were asking, I just told you to leave this right now because I wanted to go through with everybody how to simplify it. So this, I know I don't have all of the steps up here, but this is where you would have gotten to just after simplifying what's in the square root. So ladies, Autumn, can you go back to your seat, please? Make sure you have the opposite of b, which is positive 6. The square root simplifies to square root of 28, and then it's over 2. 28 is not a perfect square, and like I said, I know most of you already had this. So anytime it's not a perfect square, you simplify the square root. 28 can be split into the square root of 4, square root of 7. Square root of 4 is 2, and then you keep the square root of 7. Now, it is fine for you to leave your answer in this form. I'd rather you leave it like this is exact, versus actually calculating would get you a decimal. But there is one other thing you can do to simplify, and this is how you can check if you can simplify it. You know that you can simplify when this number here that would be in front of the square root, and then this number if they all have a common factor. So if they can all be divided by the same thing. So because 6, 2, and 2 can all be divided by 2, then you can divide them all by 2 to simplify. So really this would be 3 plus or minus, the 2 here would just be 1, so either 1 square root 7 or just square root 7. And then it would be over 1, but if your denominator is 1, you don't need to write it in, so it would just be 3 plus or minus the square root of 7. Okay, and again, it's fine to leave your answer as one expression. If you want, you could also split it into 2. Some of you were doing that. One solution is 3 plus the square root of 7. The other is 3 minus the square root of 7. So if you wanted to split it, that is also fine, but it's not necessary. If you were trying to get decimals, you would need to split it though. So that's one thing if you were trying to get the decimals. Okay, any questions on 3? Okay, then 4, you could simplify in a very similar way. Double check for 4, you would have had to subtract the 6x first. This is where you would have gotten to after simplifying the square root, so 6 plus or minus the square root of negative 16 all over 2. Square root of a negative is imaginary. So remember, this is where I could split this into the square root of positive 16 times the square root of negative 1. The square root of negative 1 is I, square root of 16 is 4. So 4I, and then same thing, if I is in your answer, you can leave your answer like this, but because 6, 4, and 2 can all be divided by 2, I could actually simplify this to be 3 plus or minus 2I. And they're not like terms, so you can't combine them. Or if you wanted to split it, one is x equals 3 plus 2I. The other is x equals 3 minus 2I. So you can split it, you don't have to. Questions on 4? Okay. Then, this next part, and I know some of you were looking ahead at this as well, which is great. This is using the discriminant to determine the number and type of roots a quadratic equation has. So the discriminant is part of the quadratic formula. The discriminant is the expression b squared minus 4ac. So it's what is inside of the square root. And you can, rather than using the whole formula to actually find your solutions, you can just find the discriminant, and the discriminant will tell you how many solutions you have and what type. So if you look back at the 4 examples I had you do, all have a different number and type of solutions. So we're going to go through this chart to explain that. But it says here in this chart, you are not going to be given this chart, so you need to understand it. The first one, this all gives the value of the discriminant and tells you how many solutions and then what a possible graph would look like. So for the first one, it says if your discriminant is greater than 0, so that means it would be a positive number, and it's also a perfect square. So if you looked back at the 4 examples we did, this would be like what happened in example 1. In example 1, the discriminant, so what was in the square root, was a positive number and it was a perfect square. Our 2 solutions for example 1 were real numbers, they didn't have I, and they were rational numbers. And I know they were rational because they no longer had a square root in them. So when your discriminant is a positive perfect square, you will have 2 real rational roots. On a graph, that would mean you have two x-intercepts. And the other case could be, again, if your discriminant is positive, so greater than 0, but if it's not a perfect square, this would be like what happened in example 3. In example 3, we still had a square root of 7 in our answer, so we still had two real answers. There was no I, but they would be irrational roots. All right, ladies in the back, can you take the earbuds out, please? Sandra, thank you. If I can hear you music, it's way too loud and you shouldn't be listening to music right now anyway. So it's a positive number. It's not a perfect square. You still have a square root in your answer. That means it's irrational. It would be a decimal that goes on forever, doesn't repeat, but they're still real. Still would be two x-intercepts on a graph. Next case would be if your discriminant is actually the number 0. So this would be like what happened in example 2. If you get 0 as the discriminant, you are only going to get one answer because you'll have whatever your opposite of b is plus 0 and your opposite of b minus 0. It's going to be the same thing. So you have one real answer and it will always be rational because the square root is gone. And what that would mean on a graph is you have one x-intercept, that's the vertex. And the last case is if your discriminant is a negative number. So that would be like what happened in example 4. That means your answer is imaginary. So it says two complex roots here. And if you answered, instead of saying two complex, if you said two imaginary, that is also okay. And that would be like we saw in example 4, you have I in your answer because you had the square root of a negative. On a graph, since you don't have real solutions, that means there's no x-intercepts. So you still have two answers, but they're imaginary. Okay, so this, second hour was like, do we have to memorize this? You have to know it. I wouldn't say it's a matter of memorizing, it's a matter of understanding what it is. When you find the discriminant, think this is the number in the square root. Can I take the square root of the number? Can I not take the square root? If I take the square root, is it going to be imaginary? And that can help you figure out how many solutions you'll have and what type. Notice you always have two solutions unless your discriminant is actually the number 0. Then you only have one. So there's a couple examples. Like I said, I know some of you looked ahead at this already. These examples, you are not actually solving the equation. You are finding the value of the discriminant. And then you're using that to say how many solutions do you have and what kind. So from that table. So if we look at the first one, equation still needs to be in standard form so you can identify A, B, and C. So in this equation, what is our A? A is what? 1, B is 3, C is 5. So the discriminant is only b squared minus 4ac. That's all you have to calculate. So for this example, it would be 3 squared minus 4 times 1 times 5. So that's 9 minus 20, so negative 11. So this is the discriminant. And now here's where I say think of the understanding part of it. This would be the number that's inside of the square root. So what type of solutions are you going to have? Are they going to be real or are they going to be imaginary? Imaginary, because you have the square root of a negative. So you're going to have two solutions, but they're going to be imaginary. So whether you want to say two complex or if you say two imaginary, either one is fine. So understand the table rather than thinking you have to memorize what it says. Okay, so why don't you go ahead, answer part B, find the discriminant, and then say what, how many solutions and what type of solutions they are. And then if they're real, you do also specify if they're rational or going to be irrational. So is there still going to be a square root in your answer or will there not be? All right, this one I'm not going to walk around. What did you get for the discriminant? Well, not 9. It would be when you take the square root, it would be 9. So the discriminant is 81. But yes, this would be, so I know I wrote the square root over the negative 11 here. The negative 11 was the discriminant. I just wanted you to picture this is what's in the square root. So 81 is your discriminant. That is what's in your square root. So then how many solutions and what kind? 2 real, and they'd be rational because you can take the square root. So the square root would no longer be in your answer. So they'd be rational numbers, not irrational. Okay, so understand how to use quadratic formula, understand what the discriminant means, and then what this chart specifies. I'm not going to read through it word for word with you. It's for your reference. This just shows the 5 methods we've used to solve quadratic equations. What I want to point out to you, graphing, it says, can be used sometimes if your solutions are imaginary or even if they're irrational. A graph is not going to help you find what they are. So graphing is really best used if you have x-intercepts that are integers. Factoring does not always work. It only works, obviously, when you can factor it, but that is not always. Some polynomials are prime, can't be factored. Square root property sometimes works if your quadratic equation is set up in the right form. However, this is what's important. What we did yesterday with completing the square and quadratic formula today, that always works. 2 methods that always work. To